Hello and welcome to this Xilinx Quick Tech video, which will briefly cover programming and real-time debugging you design after probing and implementation. You can connect to hardware by using either the Bravado IDE, graphical user interface, or by ticker commands. In either case, the steps to connect to the hardware and program the target FPGA device are the same. During this Bravado Quick Tech video, we'll cover these steps and show you how to quickly connect to the target hardware and debug your design. First, we'll show you how to connect to the hardware and program the FPGA with the bitfire. Next, we'll then show you how to set up different triggers in the IOA debug core and capture data in the common waveform window. Let's get started. The project that is used in this Bravado Quick Tech video is a simple DSP design that uses a push button on the KC705 board to select between various sine waves generated by 3 different direct digital synthesis or DDS IP cores. Before proceeding, make sure that you connect the Xilinx USB JTAG cable from your KC705 board to a Windows machine's USB port. And also make sure that the board is plugged in and power on. For the next few steps, we'll follow instructions from the dialog windows. Click Open Hardware Session and notice that the window layout is defaulted to the hardware session. Click Open New Hardware Target and then Next to open a new hardware target. Leave the server name as localhost since we are connecting locally. You will have to specify host name and port number if you were to connect remotely. Click Next to go ahead and connect to the server. Next is to select the hardware target and hardware device that you want to connect to. At the bottom of the dialog window, the tool indicates the server name and software version. Click Next to continue. And click Next again to continue. Here is the Open Hardware Target summary page, showing server and target settings. Click Finish to go ahead and open the hardware target. At this point, you have successfully connected to the hardware. Next is to program the device. You can do this by right-clicking on the XC7 K25T and select Program Device. Make sure that this is the bit file that you want to program and download to the FPGA device, and then click on Program to continue. Once the download has finished, you are able to see the available hardware IOA debug core that you inserted in your design. You also see all the debug nets that you have added during the probing phase. After we have connected to the hardware and programmed the device, we'll do some simple settings on the IOA debug core trigger and probe compare conditions. First, let's go ahead and click on Run Trigger Immediately button to trigger and compare data immediately regardless to the setting of the IOA core trigger condition and probe compare values. This command is useful for capturing any values that present at the probe inputs of the IOA core. Here is the digital sine wave at the output of the sine generated circuit. You can also change the waveform style to the analog signal type. Well, that doesn't look like a sine wave, and it is because we need to change the radix to sine decimal to display the proper sine wave. Next, set the trigger position of the IRA core to 512 at the midway point of the 1024 sample deep capture window, and then click Apply. Set compare value on the GPIO button above probe bit 1 to rising edge. With these settings, we are simply looking for a trigger condition with a low to high transition generated by the GPIO button above signal when it is pressed. Click Run Trigger button to arm the trigger in the debug view. Here you can verify the trigger occur on the low to high transition of the GPIO button above at the trigger position of 512. Next, we'll show you how to trigger when the output size signals equal to the hex value of E0029 at 512 trigger position. To do this, set the trigger position and compare value of the size signal accordingly. Click Run Trigger and zoom in to the trigger mark to observe that the trigger compare value of the size signals was correct. The IRA probe trigger comparators are used to detect specific equality or inequality conditions on the probe inputs to the IRA 2.0 core. The trigger condition is the result of a Boolean AND or OR calculation of each of the IRA probe trigger comparator results. One thing that is worth to mention here is that Bravado Debug allows user to change IRA properties as well as compare conditions such as trigger position, capture the depth, compare operator types, and etc. on the fly in real time without having to regenerate IRA netlist, resynthesize, or re-implement the design. For more information, you can visit the Bravado landing page at Xilinx.com for links to documentations, tutorials, and additional video available on other topics. Thank you for watching.